Today we're talking about bulletproof deployments, meaning bringing software from a local environment up to the server. These are the areas we're going to cover. We're going to talk about the staging or preview system. There are two names used interchangeably. We talk about CI and CD and what that is, error tracking, rollbacks, and backups. Talking with a guy who is the pro. Nico Duldhardt is a friend of mine and he was a developer and now he focuses on DevOps with a huge payout for himself.
I spent a lot of my time at Creat and in other jobs to just serving other developers, setting up the initial setups, basically enabling other developers to work properly and do the business logic. I think no one really chooses on his own to pursue a career in DevOps. I think it just happens. At some point, you just don't have a guy who is responsible for the setup and then you take over. And that's how I got into it. And over the time, I accumulated a lot of knowledge. And today there are many ways that lead to Rome, but I want to give you a small checklist of things that you can check for your own application to check whether it's a decent setup.
The first thing we talk about is the correct staging environment. And the principles for staging usually is that it needs to reflect the production very closely. It needs to be as close to the production as possible and ideally have anonymized data. If that's possible, then it's very easy to test new releases.
One thing that I think, and I think you agree too, because I saw a video of yours where you talked about staging environments, you need to have a second environment that integrates all your code and mimics production as close as possible. So basically a clone of your production system. And you never want to directly change production or push code changes to production. That's a bad practice. It's super dangerous. There are the developers, they work on their local machines. That's why I depicted it, the development environment with a computer. So it's a local developer's computer. He can do whatever he wants. He doesn't, it doesn't interfere with anyone else's work. And then the changes are committed to a code repository, hopefully, and from there deployed to your staging environment. And then you can do manual tests, maybe have some more automated tests. And then if you know that you have a stable release, you can bring it to production. In the best case, you just have to change some versions of your application. So for example, the tag of your Docker container, instead of version 1, you have version 2. That's in the best case, you can you can migrate a clone of your staging environment to production after it works. And then if you would have dev prod parity, so the difference between production and staging, if you have dev prod parity and you bring a clone from staging to production, then it's basically guaranteed that it works. In practice, it's a little bit more messy, but I would say it eliminates 95% of the errors.
Automation is non-negotiable because the thing with automation is only if something is automated, it's very easy to do. And when it comes to testing and delivery and deployment of software, we want to have this as easy as possible. So we're going to talk about CI, which is the continuous integration, test, linting, security, building artifacts for the deployment. And then CD is the actual delivery where we auto deploy to staging. And in our case, we use a manual trigger. So we need to click for the production deployment.
So human errors are the norm, not the exception. And you need to account for that. Every developer knows that from time to time, you're just in a hurry. You have a bad day, you're annoyed. Maybe you just push something that's not working. Maybe you just merge something without properly checking it, etc. Maybe you didn't run the tests because you were sure that this is just a small thing and you were sure that it should work. You assumed that it would work. I think the whole deployment pipeline should be automated. So there's one best practice. You always want to separate the build from actual deployment. So let's say we have a web application. I would say this applies generally, but let's assume we have a web application that we deploy containerized. So first we build a Docker container and then we tag it maybe with a Git hash, maybe with a Semper version. In my case, usually I do both. And then we deploy that specific container. In the CI pipeline, what we usually want to do is we want to run some tests, we want to run linting, we want to build a container. We want the container to end up in some registry where we can reliably and reproducibly pull it from if we deploy the services on our servers. However we do that, there are many ways. Then when we deploy, we basically just want to say which versions of let's say we have just one single container. Let's say it's a web application, like, I don't know, Next.js application that has the front end and back end directly integrated in one container. And then you just want to say, hey, I want the next version of the application. So for staging, what I do a lot is to just use Semper versioning. And then there are tools for Kubernetes, for example. There's image updater tool, Argo CD image updater that I use a lot, where you just, which basically just checks the registry if there is a newer Semper release. You can also do this in Bash. There are many ways to do this, but you can basically check if the version is higher, and if the version is higher, you automatically deploy the higher version. That's an easy way to get automatic deployments to staging, to just check for newer images, pull them. Of course, you can also do the same push-based. Yeah, I think the automatic deployment is a pretty important thing because that allows you to actually integrate your work multiple times a day, especially if you have a lot of moving parts that work together, maybe a whole team of developers, then you want to see that the changes that are pushed to staging first and then to production, that you want to first see in staging that they properly work integrated with each other. So test the environment or test your changes in a real environment, not just in a local dev setup before it goes to production. Depending on your release cycle for production, you would have a shorter or longer testing phase, and then afterwards you test the real application just with probably slightly different set of data. And then you can be quite sure that if you bring that staging changes to production, however that may be, earlier we talked about just changing container versions, executing migrations for the database, tested the same workflow before on staging, then there is not much room for error. So a lot of these errors are already eradicated.
Error tracking is another aspect that's super important because you can only fix the errors that you actually see, and it's important to track them on production and to also get alerts when errors appear.
So I thought about observability is a big topic, and you can spend unlimited time on monitoring your application. But one thing that I think is the most useful or the most important thing is proper error tracking. So you want to know if there are fatal errors to your application. If you have some runtime error that has a big impact, you wanna know that. So what you want to have is a system to centrally track errors. I think the industry standard is probably Sentry. There is an open source variant that's compatible with the Sentry client. It's not much work. You just 50% of the benefit, embed a little script for basically every programming language, and then it already collects errors centrally, groups them for you. So so you know what's going on in your system. What we do, or what I like to do, is because we use Slack. I like to have Slack notifications for one channel for staging errors, one channel for production errors. If there's a production error, you need to look into it directly. It's the most important thing, and then you can roll it back, fix the error, whatever you got to do. And I think it's one thing that I think is important to also enrich your errors with some metadata. That gives you, it's not a lot of effort, and it gives you a lot of power. Usually on your containers for your application, let's say your Next.js to-do list application, you can pass a few environment variables, for example, which stage it is, which version it is. I always use Zemva versions, so which Zemva version it is, which commit it is, etc., etc. So a few of these information you can just pass to the application, or you pass it anyways because it's useful for the application to have some meta information about itself. And then you can pass that to the error tracking system. And what the error tracking system is then able to do, it is able to tell you, did this error already happen in staging? And then you got to ask yourself, why didn't we spot this in staging? Did this error, over how many versions did this error occur? Is it occurring despite the fact that we're already 10 patches last week?
It's not new to me, but I like the description of an undo button. So what if something breaks in the deployment process? What if you push up a new release to the servers and you need to roll that back because there is some error?
I spend a lot of effort into getting ugly stuff out of the way. And one thing that is really important for that is to have a proper mechanism to recover from a wrong deployment. Also to take out the anxiety of deploying. I know, especially in bigger companies, there's a lot of anxiety going on to just deploying stuff because it's pretty indeterministic. A lot of errors just happen. Then they have because it's an enterprise, they have a lot of business impact. So you cannot just leave it like that. So it makes the whole process for a developer pretty stressful if he has to account for the 5% of the times where he just has an error, maybe just because he didn't look properly, etc. But it just happens. So you need to account for that. And in that case, you want to have rollbacks. You want to tell your developer, okay, of course, don't push your ugly code straight to main. But if you do a mistake, it's okay. So it's no headache. It goes to the staging environment like we already discussed. Maybe you will impair the work for some other developers for a little bit. If they, for example, let's say someone develops the front end against their React Angular Vue front end against the back end that's you just destroyed. Then you impair their workflow for a few minutes. But that's okay. They can take a break. It's not like you impair the customer. And what you want to do in this case, you want to have an insurance in place to save your weekend. Maybe for a staging environment, maybe you could leave that over the weekend. But especially for production, it's important that your rollbacks work properly. And one thing that we already talked about is that to deploy the next change, basically to go forward, we want to just change the versions, whether it may be we basically just want to change the tag of our container image so that the new image is deployed.
The thing with migrations is once you executed them on the production server, it's very hard to roll them back because the data has been changed already. It's easier to bring a software version back, but once you change data and then you put up another software, the old software back, maybe the old software is not compatible with the new data. So there's a problem. Usually it's very hard to do this, but Nico has a trick.
Unfortunately, somewhere in there, we probably need to do database migrations. And that's where it usually gets nasty. Deploying new containers, changing the tag, changing it back, etc. That's easy. That's super easy to do. But then there will be, maybe it's embedded in your one of your backend services. There is some there's some automatically applying migrations embedded in it. That's how many people, many applications do it. They just embed their migration into this backend services, into this one backend service, or maybe have a dedicated service for it that just applies migrations. And then if you have an error in your new code and you need to roll it back, then it gets complicated. It's not obvious what to do about that because usually you cannot just deploy the old Docker container tag and then the migration gets reverted. That's usually not possible. I have two tag, over time and reading about the specific issue, I distilled two tactics to deal with it. And one tactic is you want to think ahead what you need to change in the database. And then you want to make your database, make your database migrations, you want to make it downwards compatible. So that your application, if you have to roll it back, then it just works. It works with the database schema works with the new and the old version of the code. How you exactly accomplish that depends a little bit on the specific use case, but it's not that hard to figure out. In really complicated use case, what you can do is, let's say you want to restructure two tables, completely restructure them. Then what you may do is you keep the old tables. You have new tables already, and then like shadow tables or shadow columns, and then you duplicate the changes just to get that backwards compatibility. And later on, you throw the old stuff away if it's really clear that you don't need it anymore. That's one tactic. And another tactic is, let's say you just add a new feature. You don't need to refactor a lot. You just add something new, maybe just a new table, just a new column, and then you can add a feature flag.
And lastly, do you trust your backups? For backups, it's important to have a place where you store them so you have some kind of save your weekend plan. I like how Nico puts it.
It just happened recently to one of our customers that we still don't know how, but they just deleted the whole database for one server. And if you don't have a backup in plan, that can be pretty costly because it can take a lot of people a lot of time to restore all of that. Maybe it's not even possible. So you need to have, everybody is probably aware that you need to have backups in place. So you should think about, let's assume your application code is modern and stateless and you don't have anything to back up there. Then it's just your data stores. I always say that each data store is liability. That's why I usually try to push everybody to stay with as little data stores as possible. Mostly Postgres is sufficient. I recently read Figma scaled a Postgres instance to post 1 billion valuation. You can do you can do queues reasonably fast in Postgres. You can do we did full text search already over tens of millions of columns. Full text search over multiple tables, over multiple columns in each of these tables, over 10 to 100 million rows. And it worked fast. It worked in milliseconds. With the right index, etc., you can get a lot out of Postgres. So I'm an advocate for always using Postgres unless there's another reason. But yeah, for every data store, you need to have a backup strategy. And every data store is a headache. If you have two data stores, you probably have double the work. If you have an Elasticsearch and a relational database, then it's 2 times the work.
How often should you do backups? Well, Nico says daily. If the database is very small, you can go hourly. But of course, that's a question of how much data you're actually storing and how long does the backup take.
Usually daily. It depends. It depends on the SLAs. At the moment, we have quite relaxed SLAs, so we can just do it daily. But I think the way that you approach it is usually, I can just give daily as a ballpark figure. I could have also said hourly. It's a little bit arbitrary. How I usually approach it is, you see what's the business impact of data loss of 1 day. Is this a huge business impact? Okay, then maybe make it 1 hour. So is there a lot of costs involved to making it hourly? If it's a really small database, you can just do it hourly and it's no issue at all. If it's a big database, it may take more than an hour to get the whole backup. So I think it depends, but I think daily should be a requirement. You want to have it at least daily.
And now you know something about deployment. In order to do great deployment, you need to have a branching strategy so the whole team works together really well. We have a video on this, which you can watch here.